I invite Ms. Aparna and Dr. Raghu Vamsi to present their paper titled as Anomaly Detection Using Minimum Covariant Determinant as Feature in Multivariate Data.
Yes, sir. Right here. Can Ms. Aparna please share the slide?
Okay, sir.
Yeah. Am I audible?
Yes, sir.
Yes, sir, you are audible.
And the slides are also visible.
Okay, thank you. So, good afternoon, everyone. This paper, Anomaly Detection Using Minimum Covariant Determinant as Feature in Multivariate Data, will be presented by myself and my research scholar, Aparna Srivastava. I would like to give you the basic introduction. Then Ms. Aparna will take the presentation. So this particular work, so far in the machine learning algorithms, we used to reduce the features, and we used to apply the machine learning algorithms. In this work, what we have taken is the Mahalanobis distance as a feature metric, and using that feature metric, the machine learning models have been applied. And we found that instead of using the general features, if we add the additional features such as the Mahalanobis distance as a feature metric, we got the better results compared to the normal machine. So this is what the main theme of the paper. I request Ms. Aparna to take the talk further.
Thank you, sir. So let me first introduce the basic terminology. Anomaly. Anomaly is defined as set of observation which appears to be inconsistent with the remaining data. These are also referred as outliers. Detection of these anomalies is important as they can provide us with various types of information such as network attacks which are being launched, or fault in the sensors, or abnormal medical condition of the patient, or some suspicious activity in case of video surveillance. So these anomalies can be caused by various conditions such as attack being launched, or corruption of the data, or faulty sensor nodes. So we have also listed some of the application of anomaly detection that makes this topic interesting topic, an important topic, such as network intrusion detection, in the field of medical for health monitoring, credit card fraud detection, and forest fire detection. Anomaly detection is important and it has found application in various domains. So moving on to the next slide, we discuss the various anomaly detection approaches. In the literature, there have been various types of approaches which has been used for anomaly detection, right from the simple statistics-based approach to advanced hybrid approaches. A statistics-based approach make use of simple statistics and Z normal form, these methods. Then we have machine learning based approaches, distance based approaches, soft computing based approaches, game theoretic approaches, and hybrid approaches. ML based approaches, as we all know, they provide various advantages such as self learning, such as path data analysis, fault diagnosis and prediction. But these algorithms will tend to underperform if they are not provided with the sufficient input information and proper hyperparameter. At the other end, distance-based algorithm determine the outlier on the basis of distance of a point from the remaining data point, and they are proved to be very efficient. So, keeping this in view, we have used a specific distance measure, which is known as Mahalanobis distance, with our machine learning algorithm. Mahalanobis distance measure is a multivariate distance measure which is introduced by Indian statistician P.C. Mahalanobis in 1936. The equation one presents the formula for calculating Mahalanobis distance. This Mahalanobis distance is a measure of points xi distance from the rest of distribution. So formula is written as xi, the distance of xi from the mean of the population multiplied by transpose of the same quantity, which is further normalized by the covariance of the 2. As we know, covariance is a positive definite matrix by the property of covariance. So the whole quantity comes out to be a definite positive number and is a measure of the distance of the point from the remaining population. Covariance matrix also take the shape and size of the multivariate data into consideration. Mahalanobis distance utilizes this property of covariance. And it proves to be more effective for determination of outlier, as it also considers the shape of the shape and size of the distribution. It has been shown by the various researches. But one of the major drawback of Mahalanobis distance is masking effect, which is masking effect, which can be described as the uh, uh, if some outliers are present in the data, uh, then these outliers can arbitrarily affect the sample mean and covariance of the data. So that will result in the low performance of the Mahalanobis distance, because these outliers affect the overall mean and covariance of the population. Uh, to avoid masking problem, Roche et al. Proposed minimum covariant determinant distance. MCD is a type of Mahalanobis distance. It is a robust variance of Mahalanobis distance which avoid the masking effect. It is described by this formula, where instead of using mean and covariance, we are using mu MCD and sigma MCD. Mu MCD is not the mean of entire population, rather it is mean of H observation from the population, and similarly sigma is the corresponding covariance matrix. What is H? So H is the set of observation which gives the minimum covariance for the given from the given set of data. It is a set of chosen endpoint. So MCD, so the basic idea of MCD is to, instead of n sample, we are using H sample, which minimizes the determinant. The basic idea is that the points which lie closer to the mean are tightly distributed, and hereby we are avoiding the points which are away from the mean, and reducing the possibility of outlier being considered in the calculation of mu and sigma. So here these are the methods which we have used in our machine learning method, which we have used in our work. Moving on to the proposed work, this diagram figure presents our methodology of work. Our method works in two phases. In first phase, we have performed the data cleaning. In first phase is better described by the figure 2. Here we have performed the basic data cleaning and selection operation. Then we have done the formation of new data set with the help of MCD distance. We have taken the relevant features and calculated MCD and combined it with the existing clean data set, which is given as an input to phase 2. In this diagram, phase 2 is presented, where we have done this. We have chosen the machine learning algorithm from various categories. We have done the hyperparameter selection and applied both supervised and unsupervised type of machine learning algorithm. In supervised machine learning or classification algorithm, we have used isolation forest and logistic regression. In unsupervised, we have used self-organizing map and Gaussian mixture model type of clustering methods. With the classification models, we have used k-fold cross-validation method, and with clustering methods, we have first calculated the silhouette score, and by using those many number of clusters, we have performed the cluster and obtained the predicted labels. By using the original truth label and predicted label, we have calculated these parameters, which have also been calculated in case of classification algorithm. These parameters include accuracy, precision, recall, F1 score, AUC, ROC, AUC, PR, and other than that, we have also noted the time of each algorithm, time required, training time and testing time, and overall time in case of clustering for each algorithm. So our method works in these two phases. With the we have run these algorithms with regular features, and with the new feature set, which has combined MCD score. Algorithm one present a proposed approach for anomaly. Our proposed approach for anomaly detection. These are presented in two phases. Now the data set chosen, we have used WBC.
Ma'am, can you conclude your paper in 2 minutes?
Yes, sir. We have used WBC and PIMA Indian dataset, and this slide lists the various performance metrics. Here we have presented the various input setting which are used, input setting hyperparameter values. This slide presents the results. First, we have calculated the suitable number of clusters for the Gaussian mixture model using silhouette score, which comes out to be 2 after many multiple iterations. Then we have uh, then this figure 4 presents the ROC curve. We can see that in setting B, the ROC curve is better than the ROC curve presented ROC curve given for setting 1 for GM model. Similarly, figure 5 presents the AUC ROC curve for isolation forests with k-fold cross-validation method, and mean ROC value is 0.98, which is 0.96 in case of setting B. So here we see an improvement using setting B. Similarly, in case of isolation forest over PIMA Indian diabetic data set, we see an improve from 0.62 to 0.68 in case of setting 2. Similarly, this figure presents AUCPR for isolation forest, which again shows improvement of 0.03%, and figure 8 and 9 also present similar cases for logistic regression model over 2 data set. Here for self-organizing map, we have obtained the predicted label and compared with the true labels and obtained various performance metrics. There is not any significant, we do not see any significant improvement in all other parameter, but the training time has been significantly reduced. So such type of setting can be useful in this way. Similarly, table 4 is showing significant decrease in time in case of PIMA Indian dataset. Now, the table 5 presents the summary of the overall results. Here we have marked the quantities which have significant improvement in bold. Table 6 shows it for the other data set, which is PIMA data set, and our conclusion is that we have demonstrated the possibility of the fusion of MCD based Mahalanobis distance with various machine learning algorithms, and our approach utilizes the MCD based Mahalanobis distance for improving the detection of anomalies in combination with the various machine learning model. The work provides the efficacy of proposed method on different types of machine learning model. So that's from my side. These are the references which we have used in our work. That's it. Thank you for listening to my presentation. Any questions?